In this lab, we are going to talk about the containerization. So containerization has become a major trend in software development as an alternative, or we can say it's companion to virtualization. It involves encapsulation or packaging up software codes and all its dependencies so that it can run uniformly and consistently on any infrastructure. The technology is quickly maturing, resulting in measurable benefits for developer and operation team, as well as overall software infrastructure. The containerization allows developer to create and deploy applications faster and more securely. With traditional methods, the code was developed in a specific environment, then transferred to a new location. This often led to bugs and error. For example, when a developer transfers the code from a desktop to a virtual machine or a VM, or from a Linux to a Windows operating system. So containerization basically eliminates this problem by bundling the complete application code together with the related configuration files, libraries, dependencies required for it to run. This single package of software, which is also known as the container, is abstracted away from the host operating system, and hence it stands alone or becomes portable, able to run any platform or cloud free of issues. The concept of containerization is decades old, but with Docker or the open source application in 2013, the industry standard approach for container was developed. And now more than 50% of the companies are or will use it by 2021. So container basically are pretty lightweight tools, meaning they share the machine operating system kernel and do not require the overhead of associating an operating system with each application. Though, as we'll see in the lab, you can do that if in case it's required. The containers are inherently smaller in capacity than a VM and requires startup time, allowing for the containers to run on the same compute as the single VM. Thus, in turn, it drives higher efficiency, reduces server and licensing cost. So let's go and work on a container. So when we say container, we generally refer to container as Docker, and that is partially true because Docker is the most popular tool which is used in containerizing. However, Docker is not the only tool which can containerize. There are various other tools which can help us in doing that. But Docker, being the most famous and the prevalent of all of the other tools, is used nowadays. Docker also is an open source tool which can be checked, or if you want to have a look at the code, you can go to GitHub and have a look at the same. So let's get started with containers. As you can see on the screen, if we click on services and we scroll down, we are going to see the container services which are available inside ECR and ECS of containers. So just below the compute, you are going to see containers, which has the ECR or Elastic Container Registry, ECS or Elastic Container Service, then Kubernetes and the Redshift Open Service on AWS. So ECR can be used to hold the container images, whereas ECS can be used to run those container or those images as a container service. So what we are going to do in this lab will be to go and install Docker inside our instances, create few programs out of it or few containers out of it, which will be in Python, which will be in Node.js, which will be in PHP, and then we will move on to ECR and ECS. So to get started with Docker, let's first of all go to our base service of EC2. So for that, I will click on EC2 and I will launch an instance of Ubuntu. I am choosing Ubuntu. You are free to choose any operating system or any container for your reference. So I'll choose Ubuntu 20 and I'll choose a T3A medium instance over here and configure details. We are not changing anything over here as of now. The only thing that we will do is we will go and enable the HTTP traffic because we will be working on port number 80. Or we will be creating a web server. So for that reason, I will do this and I will click on launch instance. Once that's done, we will wait for the instance to boot up, and I will go and name this as Docker-node. Basically, we will create a Node.js web server on top of it. So Docker node, and now let's make a connection with that machine. For that, click on the connect button and then the SSH command. Let's open the console and work on the container now. To ensure that whether container is working or Docker itself is working or not, you can simply go and type Docker, and the command here says that Docker is not installed. Along with it is telling you what is the command to install Docker. First thing that we'll do is we'll go and update the base repo of our Ubuntu instance. For that, we go and do sudo apt-get update, which will fetch all the updates from the Ubuntu server inside it. Once that's done, we'll go and install Docker inside our machine. Sudo apt-get install docker.io. It will ask for the permission if you want to install Docker. We press Y, hit enter, and Docker should start to be installed in our machine. Now that Docker has been installed inside our machine, we can go and confirm that by going and typing Docker. And I should say that now it does not say that Docker is an unknown command. Rather, it gives us a different error. And the reason for that is I am not using Docker with the proper commands. What are the proper commands? Let's have a look at that. For example, we see version. So if I just go and type sudo docker version, it should tell me the version about my Docker, which has been installed inside my machine. Next step, we'll go and start our web servers. So for that, as we have already done in the sessions, you already know what is a Docker image and a Docker file. A Docker file is the set of basic instructions that should be written or that should be executed while creating a Docker container. This whole thing will become a Docker image, which can then be pushed either to Docker Hub or ECR or GitHub or any place where you might want to use your Docker image to. So for this reason, we'll go and create our first image, which we'll be doing it inside Node.js. For that, we will create a temporary folder or the base folder for our Node.js server. We call it node-server. Let's go inside that server. And here, if we have to work on Node.js, we have to primarily create two files. One will be package.json, which will get the libraries required to run my Node.js image. The second one being my server.js file, or the actual file which will be used to create the server. Following this, we'll also be creating the most important file for us, which will be our Docker file that will actually have all the instructions on what the image should be doing and how the container should work, build, and behave. So let's get started with the first file, which will be our base file that will tell about what all packages should be installed. The name of the file is package.json. I'll just go and copy the content of my package.json. We'll just go and change the name of the code to node-server. We will give it the base version 0.0.1. We'll give the description, my first Node.js server, followed by the author name. followed by the scripts which has to run, and then the dependencies or the software packages which has to be installed when I have to work on this package.json file. Once that is done, next command will be to write the code for the file or the server file that is actually going to execute my server. So for that, let's just go and write that. Now, because my port has to work on port number 80, I'll just go and make the port number as 80, and the host is 0.0.0.0, which means it is working on the base machine. Here, I'll just go and type the message. Node.js server running on port number 80. If everything is done, I see two files, package.json and server.js. Now that everything is done, we have to go and create the most important file for us, which is also the Dockerfile. To do that, let's go and type nano Dockerfile. We are given a new file. Here we'll have to go and write the content of our Dockerfile. I have to work on Node.js version 8. I have given that. Next step is to type the work dir, which is going to tell the base folder where I want my app to be running. This take, for example, whenever you log in into the computer or into the server, you are always forwarded to a base home folder location. That can be my documents, that can be C drive, that can be USR, SRC, that can be home Ubuntu, it can be anything. Similarly, when my container is created, I need to tell about the base folder where all of my dependencies and the program should be running. That can be any folder. In my case, it is USR SRC app. You are free to choose any location. Next, I will tell to copy the file, which is package.json. Now, whenever you install Node.js, Node.js also creates a file package-log.json. Now, because I don't want to write it multiple times, I will use the wildcard as we have seen in the previous lab for Route 53, wherein we had created the certificates for ACM. So for that, I'll choose package.json, and I will tell it to copy it to my root location, which is this. Next, I have to install the dependencies, and the command for that is npm install. So I'll just go and type it as it is, run npm install. Now, whatever packages have been installed has to be copied to my base container. So for that, I will give copy and this. Next, I will tell what port this should be enabled on, which is port number 80. So I write expose and port number 80. And finally, the command which should run inside my Node.js code. So for that, I go and write npm, start, which is the base command, which should run inside my Node.js container. If everything is good, we can type this. And if you go for ls, we indeed see 3 files are done, which is Dockerfile, package.json, and server.js. As of now, this is the only thing that we are going to do. Now that I have the base files which are required to run my image, my next job will be to go and create an image out of it. To create an image, we will have to go and build this particular image. That now that we have all the dependencies, that's pretty straightforward. For that, we just have to go and type the command sudo docker build -t, give the name of the image that you want to build. For example, I'm calling it as node server and give a dot to signify that the location of the files is this. If you hit enter and if everything is good, then it should give you the proper response. If not, it is telling me that the error is at line number 13, where cmd and npm. So let's go and fix the issue. The issue is that after cmd, you have to give a space, or else the command prompt won't understand that whether cmd itself is a command or cmd and this opening bracket is the command. So for that, we go and run this again. And now indeed we see that the image has started to be built inside my machine. First time it's going to take some time because it is going to go and download the Node.js version 8 image to your local. Subsequent builds are going to be pretty fast because Node.js version 8 image should already be present inside your local. And until unless you don't go for the newer version of Node and you are on the same image, henceforth, it should always be pretty fast. To confirm that it is indeed built, let's go and type sudo docker images, where it should tell me that an image indeed by the name of node server has been created, and that's the image ID. This image ID is the same that it told us on this step also. Now, if you see, Node.js version 8 image also is there because Node.js version 8 was part of my node server. If this is 901 MB, my image is 901 MB plus my code, which in my case becomes 3 MB of code. Now that our image is built, let's go and run it. For that, we will type sudo docker run name of the image. We will have to map it to a port, which we'll say 80:80, and we will run it in detached mode, which means it is always going to run. Space name of that particular repository. If everything is done or if everything is good, it should basically give you the response. If it is not doing, it means we have done an error over here. If you see, I have written this node server twice. So for that, what we'll do is we'll just go and remove this sudo docker run -p 80:80 -d and node server. And if I hit enter, I should see my node server should start to run on port number 80. To confirm that, let's go copy the IP address and check out on a new tab. And I should see the response coming up, which is Node.js server running on port number 80. Now, if in case I need to make a change to the code, for example, right now it says Node.js server running on port number 80. If in case I need to make a change into that, for that, first thing I'll have to go is to go and change my file. So instead of this Node.js server running on port number 80, and let's say this is the updated code. Now, if I just go and run it, it's not going to work because I'll have to go and build my complete image again. So for that, I'll go sudo docker build -d, done. If you can see, the image ID is different this time because I have rebuilt it. Also, the next time it took very less time in building. The reason is the dependencies of Node.js 8 is already there or the image is already present. Next step, we'll have to go and stop the existing container which was already running. To view the existing container, you can type sudo docker ps, where it will show you the container. Now we'll have to go and stop it. So for that, we go and type sudo docker stop and name of the container. Once that is done, we can go and build or run the image again. For that, sudo docker run -p 80:80 -d and the name of the particular image, which in our case is node server. If I do that and I refresh my page, I should see the code being updated where it says this is the updated code. So this is how you can go and work on Node.js, and you can go and containerize any of your Node.js application. Now that our Node.js code is already working, we will go and do the same thing for our Python web server. For that, we go to our home folder and we will create a new folder by the name of Python-server. Here again, we'll be repeating the same steps in which inside Python, first thing I'll have to go and create my Dockerfile. Then I'll have to create my Python server file, which we will call it as app.py. Along with that, it might require certain additional files, which we will call it as requirements.txt. So let's get started with that. For that, we go inside our server. We go and create the file, which is requirements.txt. And here we'll give the requirements, which is required to run my Python server, which in my case is Flask and Redis. Once that is done, we'll have to go and give the Python program to get the web server. You are free to choose any Python program for the web server. In my case, I already have the code, which is here. And if you want, you can pause the video at this moment and take the code from here. Or again, you are free to go and choose a Python server of your choice. Now that this is done, the last job is to go and create the Dockerfile. So for that, first step will be to go and get my image. So last time, as we have seen, the Node.js image was 901 MBs. So 901 MBs is a pretty big image. And if we need to deploy it inside a server, that takes up a lot of resources. Similar thing happens with Python also. However, in case of Python and even in case of Node.js, we can take a slimmer version of the image. This one is known as any slim image. So you can call it by a slim image, or even a compressed version of that is known as the Alpine version. So what I'll do is I'll go and take a slim version of that, which I will call it as Python. And the version that we use is 2.7-slim. Next, like last time, I'll have to go and set the root folder. I'm setting it to app. Then I will have to copy everything from my location to that folder, which is app. Then I will have to go and do the pip install with trusted host, which is python.org. And the requirements I'll take is from the previous file that I had created, which was requirements.txt. Next, I will, because this is working on port number 80, I will expose port number 80. Then if I want, I can give the environment name, which I'll call it as world. And finally, I'll run this code by cmd and python, epp.py. And if everything is done, we can go and build this image by going for sudo docker build -t. Let's call it as python-server, and it will be built on this location. Just like last time, this time again, first time it will take some time for us because it is downloading the image of Python 2.7-slim. Python 2 is generally discontinued now. However, if you are working on Docker, it shouldn't be a problem for you because Docker supports multiple systems and environments and runtime. This also happens to be an advantage of Docker, that if in case you are working on Docker, you don't have to worry about the base source code or the environment of that particular code. Now, if the image is built, let's go and check that out by typing sudo docker images. I do see my Python server created. If you have a look earlier, Node.js was for 901 MB, whereas Python is only for 148 MBs. If you see, this is pretty old. Node is 18 months ago and Python is 14 months ago. The reason for that is we are using the version of Node and Python, which are very old and generally discontinued. If you want, you are free to choose any version, though this should also not be a problem for you. To confirm that it works, we will have to go and run it. For that, we go and run it by sudo docker run -p 80:80 -d detached mode, and we give the name of the image and it will error out. The reason for it is given in front of you, where it says that the port number 80 is already allocated. And indeed, port number 80 is already allocated to our base image of Node.js. So there's already a container which is working. To test it out, sudo docker ps. I indeed see that my Node.js container is working since 5 minutes. So first thing that I will have to do is I will have to go and stop this. So for that, I go and type sudo docker stop this. And next I can go and run my Python container. Sudo docker run -p 80:80 -d and the name of my Python server, which is this. Now, if everything is working, I go back to my page and I refresh it and I indeed see hello world, host name and the visits coming up. This is because I am now running a Python container over here. So this is how we work on the Python images. So we have seen already the Python images, and we have also seen the Node.js image. Our third part will be to go and work on a PHP image. For that, we will have to go and get the runtime of PHP. So basically, it simply means us going and getting on the top where we give from Node 8 or Python 2.7-slim, we'll be going and giving from Python or from PHP and the version of that particular runtime, which in our case is PHP. So let's go and get started with our image for PHP. For that, let's go and create a folder by the name of php-server. This folder can be anything. I create it like this so that it becomes easy for me to understand that where exactly my base images are located. So you are free to choose any folder or any name for that sake. So first thing that I will have to create here is my sample hello world PHP program, which will have the hello world like we had for Node.js and for Python. So for that, let's go and create it. I'll name it index.php, and I'll start with the PHP, and I will say echo hello world. This is, and I'll just break it. Okay, if echo is there, let's just go and close it. Fine. If this is done, our next job will be to go and get my Dockerfile. Now, just in case if you are wondering that why don't I need a, like inside the previous one, I had the package.json, and inside Node.js, I had my package.json. Inside my Python, I had requirements.txt. The reason for that is inside Node.js, I had to do a npm install to get the base packages or requirements which were required to create the server. Similarly, inside Python, I had requirements.txt file, which in case were the base requirements to run my Python server. In case of PHP, I am directly going to go and take help of PHP Apache server, which comes bundled in, and that has the dependencies already which are required to run my PHP server. So for that reason, I don't need any external software to work on that. So what I mean is I'll go and let's say nano Dockerfile here. Inside my from, I will give PHP, and let's give the version of PHP-Apache. So this particular runtime or image itself will have everything which is required to run my PHP image. So for that reason, I don't need any external file. Next will be to copy everything to my folder, which is var www and html, and then expose and port number 80. Basically, this is going to do the job for me, and it will start the web server on port number 80. To test it out, we'll have to go and build it. So let's go and do that. Sudo docker build -t, and I'll have to give the name. Let's call it php-server and build it inside my location, which is PHP server. So once that is done, let's just wait for it to happen. Once that is done, I should have my PHP server up. Now that I have my image which is built, that can be seen by typing sudo docker and images. I do see my PHP server image has been built. To go and run that, sudo docker run -p 80:80, and then -d if I give, when I give PHP server, it's again going to error out because this time my previous web server of Python was already working on port number 80. So there are two ways of fixing this. Either you can go and start your new container on a different port, or you can go and stop the container. Now, because I have only enabled port number 80 on my instance, so for that reason, I am going and stopping my container. Now, this is in no means, it means that you can only run one container at one time. You are free to run as many containers as you want. So for that, I'll have to go and stop sudo docker stop and the container ID. For that, I'll go and do sudo docker ps. To stop it, sudo docker stop and the container ID here. And once that is done, we will go and stop or start our PHP server. So let's just wait for the container to stop first. Now that it is done, to confirm that it's not working, sudo docker ps, and I don't see any running container. Now to run that particular container, sudo docker run -p 80:80 and giving the name of the image, which is PHP server. If I do that basically, and if I go and refresh the page, it gives me the new message, which is hello world, this is a PHP server. So basically what we have done is we have gone and run 3 images, one for Node.js, one for PHP, and one for my Python web server. Now, if in case you want to run any, so this containers you have gone and built. So if you go and refresh the page, it is going to tell you that what operating system is actually opening it, what is the WebKit, and what is the version of the Chrome, what they are using in that machine, because I'm opening it from here. So that is why it tells me like this. If in case I open it from any different device, like I'll do that now. In that case, it will give us the new logs. So let's have a look at that. So if I open it from a different phone, it's going to give you the message like this. So basically, this is just the logs from where you are trying to hit that particular machine or that particular web server. If I want, I can very well stop it, and then my container basically stops. Now, these containers we have actually built, so it is giving us the customized message. In certain cases, you might want to go and run the normal containers or the images which are present with your Docker Hub itself. So for that, let's go to Docker Hub first of all and open that. And let's say if I have to run a base server of, for instance, Apache. So Apache image is HTTPD inside my Docker Hub. So if I go and search for HTTPD and click there, so it should give me the command. So either you can first go and do a sudo docker pull HTTPD, or you can go and directly do a sudo docker run HTTPD. So that's what I'm going to do. Sudo docker run -p 80:80 and then HTTPD. Now, because it doesn't find the image locally, it is first of all going to go to Docker Hub and download that particular image. Once that's happening, it will go and start running on that particular server. So let's do that. So if I try to open that now, I see the logs over here. Or if we have to check it in the browser, let's do that. If I refresh it, it says it works, which actually is the message which my Apache container is giving as of now. So this is how you can go and create your images in EC2. In general, you are free to go and choose or create an image of any runtime. In my case, I chose Node.js, Python, and PHP. You can also go and take help of any existing image, for example, HTTPD or Apache. You can even take nginx or any container that you want. So if you want, you can do that also. Now the next job will be to go and run the same things using ECR and ECS. So that's what we are going to do now. So in this, what we are going to do right now is, let's say there is another web server which is known as nginx. It's a pretty popular web server like Apache. It's mainly used, and if in case you have to do a reverse lookup or something, this is actually used a lot. So if you have to do that, just go and type sudo docker run -p 80:80 and give the name of that particular image. If you do that, basically my container of nginx should start. And if we now try to go and hit the IP address here, I should see something as welcome to nginx. So we have seen three services or three servers which we created ourselves using the programming language, and two of the web servers which come bundled in with my containers of Docker Hub. The two most popular ones, which are Apache web server and my nginx web server. Next step will be to go and do the same thing using my ECR and ECS. So for ECR, what I'll have to do first of all is I'll have to go and create a user which will have access to my Elastic container registry. So if I need to go and give someone access to my Elastic container registry, what I will have to do is I will have to go and create a policy which will have access to ECR. So the way we work on ECR or any service of AWS is that first thing you will have to go and give the permission to that user to use that AWS resource. In case it's a user, you go and attach the policy. In case it's an AWS service trying to access another AWS service, you will have to go and create a role out of it. So in this case, what we'll do is we'll go and create a policy and we will attach it to a particular user, and that user should be in AWS CLI. So that step we'll do next. For now, step number one to ensure that my services are working on ECS is step number one, create the policy for ECR. Step number two, create the user, attach this policy to that user. Step number three, install AWS CLI inside your machine. Step number four, attach this CLI to the user that you created. Step number five, the image is already there that you had. And step number six, use your ECR to push this inside your ECR image. And then if you want, you can go and take help of ECS to deploy this. So that's what we are going to do now over here. So for that, first thing that we will do is we'll go to our policies and create a customized policy for my ECR. So for that, let's click on create policy and let's write down the policy. So there are two ways of creating a policy, a visualizer and the JSON. I'll choose the JSON method. The only thing is don't change the version number over here. So let's do that now. Fine, if everything is good, tags. You can add the tags whatever you want. So let's call it as name ECR-EC2 server. Give it a name ECR-EC2 and you're free to choose anything over here. So if you see, basically it is telling you that you have chosen ECR, and because I gave star over there, so that effectively means that it can do anything inside my ECR or Elastic Container Registry. Now, if this is done, we'll go and create a user, and this user should have access to ECR. So for that, we click on add user, and let's call it as ECR-EC2, and the programmatic access. Here we'll have to go and attach the policy that we created some time back, which was ECR-EC2. To confirm that, expand it, and it should say that it is allowing everything, like just we did. Review and create the user. Once everything is done, you have the access key ID and the secret access key that can be used. Now, the next step will be to install AWS CLI inside my machine. For that, you can type AWS. It should error out, thereby also telling you the command which should be run to install CLI. So let's do that and wait for it to happen. Now that it's done, let's go and configure our user. For that, we'll go and type AWS space configure, and it will ask for the access key ID, which is this secret access key, my region, which happens to be Mumbai AP South 1, and the output format, I am setting it as table. Now that this is all done, the only thing left is to go and create the Elastic Container Registry or ECR inside my machine. So for that, we go type ECR and we go and search for Elastic Container Registry. At this point of time, you will have to go and create a repository by the name. So because I'll be running the Node.js server, so I'm just going and naming it as node-server. And I'm creating it. If you want, you can also go and encrypt it via KMS. If in case you want, you can just go select node server or click over there and click on view push command. As you can see right now, I don't have anything over there, and that's fine because there's nothing inside the image at the moment. So let's click on view push command. I get the command as it is, and I'll go inside and I'll hit enter, and it will error out. The reason for that is you are giving AWS ECR get login password. That's pretty fine, but installing Docker, we have installed it with the sudo command. So what we'll have to do is we'll have to go and put the sudo command also. So for that, I copy that, paste it, and over here, I just go and type sudo before that. And this command, if you go, it should go and do the login inside Docker as it is. So if it is done, it will tell you that the login is succeeded. Now, if everything is done, let's go and build this. But the thing is, we'll be building it inside our node server. So for that, let's copy this sudo and build. As you would have realized, it takes quite less time because the dependencies of Node.js and the other dependencies are already installed. Next step. And finally, I'll be doing the push for that sudo. And now if everything is good or till here, it should go and push this particular image inside my ECR. Now that it has been built, to confirm that, let's go back to our repository in ECR. And if we open it, we are going to see that indeed I have the image which is present inside my ECR. Now, if this all is done, this is how you go and push your image to ECR. By the way, there is one more place where you can go and push your image. That is called as Docker Hub. So Docker Hub is the product from Docker itself. So just in case you want, you can also push it to Docker Hub. So let's do the same thing here also, just in case if we want to push it to Docker Hub. So for that, you just have to go and type sudo docker tag. First of all, we need the image name. So for that, sudo docker tag, and let's give the image name. So our image is this, and we will be calling it as and like slash, let's give it any name. So let's call it node-at-server. And if that is done, you just have to go and do a push, wherein you are going to see an error right now. And the error would be that you will have to log in. So I am asking Docker to go and push it to this particular user. But first I'll have to go and validate that whether I am the authenticated user for this repo or not. So for that, I just go type sudo docker login. It will ask for the username, password. And if everything is done, let's now go and do the push. Finally, if everything works good over here, we should be seeing a new repo coming up over here pretty shortly. So let's just wait for it. And I should see the image coming inside my Docker Hub also. Right now, it's not there because it's still pushing it. One thing that you will see is it is mounting it from library or node itself. The reason is Docker Hub itself has Docker. Basically, whenever you are doing any sort of a pull, you are doing it from Docker Hub itself. So let's go back and refresh the page. And if I do that, I'm going to see that my server has indeed been created, or my Node.js image is present inside Docker Hub. So if you want to have a look at it, you can click there and it will show you the image. So you can click there, and basically this is what is happening inside my particular image. So you might find these commands already where we did a npm install, the expose, the cmd, the command, and the Node.js version. So this is exactly what is happening inside my image. The vulnerabilities, I don't have anything because this is not a paid plan, but however, if you upgrade to pro, you can do that. However, in case of ECR, if in case you want to do that, you can do that. So if you go back to your node server and you select this and you click on scan, ECR is going to do the scan for you to figure out if there is any vulnerability issues with your particular image. Now that my repository for node server has been created, we can go to the final task of running it as a Docker service inside ECS. So for that, I go type in ECS or Elastic Container Service, and we will start by creating things in ECS. So for that, first of all, let's go and create a cluster. For that, we click on create cluster, and let's make it on EC2 Linux with networking. In the next step, we'll have to create a cluster. Let's call it -node-cluster. Instance can either be on demand or spot. It depends on you. I'm choosing on demand because I want it to work. However, you can also go for a spot because spot gives you a lot of discount as compared to on demand pricing. However, as you already know that it's not always important that you are allocated the spot request, because that happens based on the bidding and on the availability of that resource at that point of time. So for that time, that reason I am selecting a T3 instance. I'm choosing a T3A small instance, and I need one machine, and I am free to choose any of the AMIs because this is working on AWS, so it is choosing the AMI. If you want, you can select a key pair. If you don't want, you are free to leave it. If you select a key pair, you can log in into that instance using that key pair. However, it's always advisable not to do that because you shouldn't be having the access to key pair. If in case you need to go and deploy anything again, you can do it manually, or you can create a new cluster for that site. And networking, I will choose the existing VPC, which I already have. And I am going and allowing port number 80 so that I can run my web server and I can see that indeed it is working. Now, if I click on create, I will have to choose first of all a subnet and create. This might take some time, so let's just wait for it to complete. Now that the cluster has been created, our next job will be to go and create a task in this case. And that task will be the thing that will actually be running my particular image. So for that, we can click on task definition and create a new task definition, which can be again on EC2 or Fargate or external. I'm choosing EC2 in this case. Next step, let's call it as a node-server-task. And let's give it some RAM, let's say 512 MB. Now that it's done, let's go and allocate some RAM to it. So let's call it 1 GB here. 1 GB, I'm giving it RAM of 1 GB, and I need to create a container now. Now to create a container, I'll have to go and give the name. So let's call it as a node-container. And the next step will be to select the image. The image is this. So let's go for the image URI, copy the complete thing and paste it. Now, if everything is good, I'll just have to go and map the port. So because this is working on port number 80, I have to do that here and click on add. Now that my container is all good and set, I can choose create, and I have my node server task which has been created. Now the only job left is to go to my cluster, go to my task here and run the new task. And this task will be whatever task I have created. So let's say I'm calling it on EC2, which is working over here. And then if I click on run task, in this case, if I go on external, or I can go for this capacity on whatever thing, because I created a node cluster here. If I click on run task, this is basically going to go and run my image. And what image? It will be the Node.js image. So just waiting for some time. If everything is good, you should see the ECS services also working, and the task, basically whatever you created, is working on this particular container. So this is what we wanted to see. The thing is that everything is working over here. And if in case required, you can go and modify the settings of your ECS cluster. So this is what we wanted to see also. Now, just one thing, if you want to see that it is being mapped on a port, if you want to see the port number, you can click on the IP address here, this and this, and it should give you the response that hello from this, and whatever container you created is going to show you that. So this is what we wanted to do in case of ECS. Now, if in case you want to remove, you can just click on deregister this here and deregister, and it should be good for you now. The last thing, if anything that you are working inside your ECR or ECS is all working on EC2 itself at the end of the day. So if you want, you can go to your instances also and have a look. It will anyhow have created a ECS container for you. This IP is the same that we had selected some time back over here. So if in case you want to go and update it, you can do that also by clicking on update cluster, and That's pretty much it in ECR and ECS. So in this session, what we did was we created a container or a image using Node.js, using Python, using PHP. Then we went and we created or ran the image for my Apache web server and nginx web server. And once this was done, we went and had our images in ECR. We updated it to ECR. And once that was done, we went and ran the same thing in ECS. Now, if your ECS has run and you want to remove it, you can just go click on delete and type delete me here. And if you click on delete, this particular thing is going to get deleted as it is. And let's just wait for it to get deleted. Now that the cluster has been deleted, you can, if you want, you can also go and delete the task that you have created inside ECS. However, I'm going to leave it as it is. You are free to go and delete it as you deem fine. Now that everything is done, you can go back and you should see that the previous ECS instance that was created has automatically been deleted, and the reason for that is that the cluster itself has been deregistered and deleted. So I'll go and terminate the instance itself, and you will now move to the assignments wherein you will be creating the similar images, and optionally you can also go and do the same inside your ECR and ECS. So this is it for this session, and I'll see you in the next one.